Welcome to this video. Here we'll be learning about graph transformations, in particular translating graphs. Now, unlike what you've learned, translation in this context doesn't mean looking up words in a dictionary or using another language. Translation of graphs means, in other words, shifting of curves either to the left or to the right or up or down. Okay, so the general shape of the graph remains unchanged. We move the entire graph in one direction or the other. So there are two translations that we have to perform here. The original curve is given to us by y equals to x squared plus 2x. And here we have the original curve, but we added one outside of the function. So let's just plot the original quadratic here. The original quadratic looks something like so. All right. Then we're going to consider this. What does this plus 1 do at the end? We adding it after the function. We evaluated x squared plus 2x, and then we adding on 1 afterwards. So what you notice is that the y values are basically the same y values, but they shift up by 1 unit. All right. So all these are just going up by 1 unit. All right. So because there's nothing that we did to the x values here, we just added it after we evaluated the x values. So the graph will simply move up by 1 unit. So this is called translation upwards by 1 unit. All right. So in this next function, the original function is remaining as it is. X squared plus 2x is what the original function is. But we are taking this notation here, x minus 1 inside of f bracket, means that everywhere we had x here, where we had x squared, we actually having to subtract 1 from x before we square it. All right. And here when we had this x here, we have this x, we subtracting 1 before we actually multiply the value by 2. All right, so this is when the change happens inside the bracket, right? Inside the bracket or the function, the change will be inversely applied, all right? Inversely, and it affects the input. By input, I mean the x value or in x direction. All right. So when the input is changed, the change will come in x direction. Now, I use the word I for your mnemonics, so you remember as a hint for your memory exercise. So the change is happening in x direction. That means that what do you think is going to happen? This minus 1 actually, as I was trying to explain with the reciprocal curves, is actually taking the y-axis and shifting the x and y-axis 1 unit to the left. All right, minus 1. So what you notice is that the graph will, if the graph red line remains where it is and the y-axis is at over here, is as if the graph have shifted to the right. Now we're not going to see the x and y-axis move. The x and y-axis remain where they are. The graph actually moves to the right by 1 unit. All right. So when I plot it, you see those values from the table will have moved the graph 1 unit to the right. All right. So I know here we took away 1 away from the x, but I said the effect is going to be inverse. If it's plus 1, it would have moved the other way. All right. So let's look at another example here. So in general, to summarize what we learned, when the change here is outside of the function, outside, it will affect the output. By output we mean y. in y direction. The change will come in y direction, and it will happen ordinarily. By ordinarily, I'm trying to emphasize that O should, it means that if we add something else after the function, it will be a plus. This is a is positive, so plus a will be plus a here. If this was minus a here, the vector would have been, this indicates the x value, this number on top of the vector, and the number at the bottom of the vector indicates the y value, would have, or the shift that will happen in the y direction. Now, when the change I try to explain to you is inside the bracket, remember the change affects the input inversely. Alright, that's why you actually see a minus sign in front of this a, because x values will move in the opposite direction. Alright, or rather the graph will move in opposite direction. Alright, so let's consider this red line here and this blue graph here, red and blue graph. Alright, so the original x cube will look something like so. What happens when we add, let's see the other graph. This is, yeah, this is when you took the x cube and we added 3 inside the bracket. It actually, imagine that x and y axis moved 3 units to the right, we adding 3, so the graph would have moved to the left, wouldn't it? As if the graph, this origin, the intercept was at origin, is now at minus 3 here, right? So this is what's happening. All right, and let's look at the other graph here. X times x minus 2 has roots at 0 and positive 2. So this is the original g function of g of x. So next here, the blue line is going to, the effect is in x direction because the change is happening inside the bracket, and the change is actually going to be, if you think about x and y axis moving 1 unit to the right, the graph will have moved 1 unit to the left. So therefore, the new roots will be at positive 1 and minus 1. All right, so let's see. All right, as I said, the the graph will move in the opposite direction to what it's saying inside the bracket. All right, because that means that x and y axis shifted to the right by 1 unit. Now, so here is summarizing that again. Now, I've tried to think about, like, when you fast forward the video, let's say you watch my video for 20 minutes and you're dragging this start here to 20 minutes into the video. What's happening is that the video doesn't change, the video remains where it is. You're shifting the frame forward by 20 units or 30 units or however much. The video is where it is. Here the graph is really where it is. We shifting when we adding something inside the function. Look at this, x and y axis move by a units to the right here. So that's why really you think that, oh, the what appears as if the graph moved to the left by however many units, by a units, and the opposite effect is down here. If you take this frame back here, move it back, subtracting minus 30 from input, it's really shifting the frame back by 30 units. So it's as if the graph moved to the right. All right, so the change was rapid here. So we changed the frame back by 30 units. So the graph seems to have moved to the right. Right? So that's my explanation of translation effect. I know it's not easy to get your head around it. It's rather counterintuitive, but once you practice, it will fall into place. All right. So let's have a look at this exercise here. This next example, x squared. We'll have to we have to translate it. So let's just sketch y equals to x squared. So that's not hard. That's something like that. When the minus sign is inside the bracket, the graph will move left or right. It will move 2 units to the right. All right. Okay. I should have waited before that happened. So let's draw the blue line here. So, okay, when x is 0, its intercept will, you know how to find the intercept, I'm not going to tell you. Then here, the change is, this plus 2 is outside of the function because we evaluated x, we squared it and everything, and then we added the 2. So we call this change outside of the bracket, outside of the function. Therefore, what do you think? In which direction and how will it change? The shape of the graph will remain the same, but it will translate up or down. I hope you're saying up. Alright, so let's see the effect of the part C. This time, yes, it was moved up by 2 units. Forget about that. That's from the previous answer. Alright, so that was that. So I've tried to make this clear to you as possible. Let's see reciprocal curves again. 1 over x is just h of x. So that's the shape of original shape. Now, when we having a plus 1 outside of the function, it's clear here that this plus 1 is outside of h of x. So does it affect x or y asymptote? Think about the asymptotes. It has a vertical asymptote at x equals to 0 and the horizontal asymptote here. You think about it, it will have shifted the y-axis. This I'm saying the new horizontal asymptote is y plus 1. So as if this x-axis has moved 1 unit up. So the graph will have moved 1 unit up. Alright, so that's my explanation of things, and I hope you've enjoyed it. And good luck practicing with translation effects. Let's see, is there another? Um, yeah. So we're just finding what's the coordinate of intersection here. When y is 0, okay, we're trying to find this point of intersection for sketching. So we're setting y equal to 0, and we're solving this equation. So we're going to have -1 on the other side, and then multiplying by x will be a -1. Alright? So that's saying what's the intersection point with the graph. Now here is something I've provided for you in the Word document. And if you remember, we completed the square, and we said that this is the original x square graph. After completing the square, where is the turning point going to be? Now I'm going to just do one example for you so you know what it means and you can complete the rest. This completion of a square tells us that the turning point is going to be at 1 and y value will be at 7. Now do you see why this change inside the bracket will turn the graph or translate the graph 1 unit to the right and 7 units up. So the new turning point will be somewhere up there where x value is 1 and y value is 7. Alright, so this vector, translation vector, is 1 and 7. Alright, so that's enough to get the hang of things. Just by looking at the turning point, you can figure out what's the equation. Try to write it as a completed square form. You don't have to expand the bracket, and write what these two values for the translation vector are. Alright, good luck practicing, and I'll see you in the next video.